Okay, so concurrency is about multiple things happening seemingly simultaneously. If you think about the way that you interact with a typical application these days, oh, think of like a web browser. In a web browser, you can have multiple tabs open simultaneously, and within each tab, stuff can be going on. And while all that's going on, you can also be downloading a file, and all that's happening again simultaneously. Up until now, the programs that we've been writing have been single threaded, or a single thread of execution, meaning you just kind of start and you keep going. The idea of concurrency is that at least what what can happen is that multiple things can be going on simultaneously. Even if there's only one logical core processor on the computer, you can still have this illusion of concurrency. What the multiple cores have done is that if the language supports that, and Java does, is that it allows parts of the program to be run on separate cores, which means essentially they're all running simultaneously. Now, why would you want to do this? Well, in part, it comes up, it kind of bites you immediately when you start doing graphical user interfaces, which are going to be the next major topic that we talk about. With a graphical user interface, there's at least one thread which is concerned with displaying the interface to the user. Behind the scenes, though, there's often a lot of things going on which aren't necessarily visible. An example of that, again, is like if you download a large file on your browser, then that download keeps going even as you continue to browse. That would not be possible if it were not for some form of concurrency. So what we're going to do is we're going to, starting with kind of the bare metal, we're going to start with these threads and this interface called Runnable. And we're going kind of moving forward past that, we're going to basically ditch the thread, but stick with the Runnable. And well, we're going to go to something called a callable, which is, so we're actually going to throw both of these overboard to one extent or another. However, it's important to kind of understand what's going on with the thread. So there's a Runnable interface, and it has one method called run. And the idea is that you never call that directly. There's a class called thread, which actually implements Runnable. And so it's one mode of operation is to subclass thread. It turns out through experience that that's not the ideal way to do things, even if we're working with threads. So a better way to do that is to write a separate class that implements Runnable and then pass it to the thread class in its constructor, and then use the instance of the thread to kind of do stuff. So in general, you want to avoid subclassing the thread. And what we do is we don't call run, we call something in thread called start. And then something interesting happens with start is that start returns immediately and keeps going. So we just have to be mindful of that and aware that that's going on. We'll see some examples if I if I can remember when I do the code. So now we're going to use something called sleep, which is thread sleep. Notice the syntax, and by the syntax, can you tell what kind of thing the thread class is? Or I'm sorry, the sleep method has to be a static method of thread because we're calling it not with an instance, but with the class. And what that does is that takes the current thread and it puts it to sleep for a certain amount of time. And the long argument is the number of milliseconds that it gets put to sleep. So all this, if we have multiple threads all running at the same time, then it happens, quote, simultaneously. Now, sometimes it literally happens simultaneously when the virtual machine is able to run each thread on a separate core, and then it's literally happening simultaneously. However, as I mentioned, even if there's only one core available, then it still looks like it's happening simultaneously. Okay. So now, after we do that, we're going to move on to something called executors, which can manage these thread objects. And there are three that we'll look at. One is called a cache thread pool, and basically that's analogous to one of these data structures. So a thread pool is a cache thread pool is something that you just if I need a new thread, it just kind of goes in, and so that's to be used when we don't know ahead of time how many threads we're going to need. This is useful when you're just kind of putting things together. It can be a little dangerous because each of these threads consumes system resources. The term thread is actually sort of the opposite of something called a process. A process is kind of a heavyweight thing that runs on the computer. So a Java virtual machine is a heavyweight process. The idea of threads are kind of thin, and so they consume fewer resources, but they do consume resources. So if you have a bazillion threads, that cannot be so great. So therefore, ultimately, for most production, we typically have a fixed thread pool, meaning that you create a certain number of threads, and then even though you can run, so let's say I create a fixed thread pool of 5, because I don't want to, for a variety of reasons, I don't want to run any more than 5 threads at a time. I can put in as many, I can submit as many threads as I want, but what it will do is it will execute them up to 5 at a time. So if I put in 10, if I submit 10 threads, it'll execute the first 5. And as it finishes one, it'll go grab the next one and keep going until all 10 are finished. And then finally, if sometimes I want to make sure that I only run one thread at a time, and that's with a single thread. So a single thread pool is exactly the same as a fixed thread pool with a pool size of 1. So we'll see what that's about. And then finally, and this is leading towards what I'm asking you to do, is that there are another pair of interfaces, only one of which you'll be explicitly dealing with. And that is the callable interface. And the idea of the callable interface is that we want to return something. See, the problem with a runnable is that this run method, which is where all the execution takes place, it has a return of void. In other words, if I have a runnable thread, everything that happens has to be inside of what that run does. Whereas with the callable, what I can do is I can say, for example, I can define a task that implements a callable, and now it has a syntax of generics, very much like the data structures that we were talking about, sets and lists and things. So this says that the call method is going to return a string. Now, when we use this, it turns out that we don't actually directly use that return. There's something called a future interface. And what it does is it represents the pending results of a callable. And what happens is that when we submit one of these callables to an executable executor service, then it returns one of these things called a future. And we'll see about kind of grabbing those futures. And it has a method called get that returns the result of what the callable returned with its call. So if that doesn't make sense yet, it will once we get to doing some code. Okay, so now I should have you completely confused, but let's take a look at this. Zoom keeps. All right. Oops. Sorry, just gotta. Okay. Okay, so let's create a new package. I'll call it threads. Okay, so let's okay, so this is going to be a instance of this class are going to do something. Okay, so at the lowest level, we implement runnable, and runnable has one abstract method called run. So okay, now since I'm going to do a bunch of these, I want to make sure that I identify each one. And so I'm going to use this approach that we had. Which is to set the ID to the next ID and then increment the next ID. Okay, so that kind of ensures that each of these will be unique. Okay, so let's have another instance variable called number, and what that's going to do is so here's our run. Our run is where all the action is going to be happening. So let's do a printf. So I okay, so again, what's going to happen is run is where the action is going to be. And so what we're going to do is we're going to loop over a certain number of times. And so, and number is how many times we're going to do this. All right, so let's do a printf. So we'll just sort of print the ID and what loop we're on. And then we're going to sleep for a little bit. So let's sleep for 1 second. Now, you notice that it's, okay, what is it complaining about? Unreported exception. So now tomorrow we're going to talk about exceptions. We've been seeing them for a bit. And well, and we've also been seeing how NetBeans puts in this logger thing where we're going to talk about what logger is about. And when we're all done, okay, so now what is happening in the run method it shouldn't come as a huge surprise to anybody. I mean, this, with the one exception of this thread sleep business, everything else is just very straightforward. We have a for loop. What I should, yeah, okay. So we're just going to loop around this that many times. So let's see what that looks like. So let's create an array of these guys. Oh, let's start with just 3. And then for each of these, let's see what we have to do. Okay, first now, remember what this does. We have instantiated an array of runnables, and I'm just making them runnable because that's all it needs. But I do need to instantiate it. And I need to say how many times I'm going to do this. Let's make it 4 just to, okay. Then what I do is I put this in a new thread. They say target, but my target is actually going to be my runnables, the ith one there. And then having done that, I start it. Now, if why are you in the file? Don't tell me did I. Yeah. Okay. So now, if we're thinking in single threaded mode, which we've been doing up until now, just think of what's going to happen here. So for each of these threads, what's going to be happening, we're going to kind of loop around, we're going to wait a little bit, and then print something out, and then keep looping until we're done, and then we're going to say that we're finished. Okay, so what is this going to look like when we run it? And it looks like I forgot to put a, oops, yeah, I didn't put a percent in here. Let's try running this again. Okay, so something interesting is happening here. Notice that we started 2 of these, not in the order we created them, and then we said all done. And then we started the next one, and then we had, look at the order, 210, 201, 201, 2, 2, and finished, 3, 3, finished. Okay, so this should show you that things are not quite what they seem when we're doing multiple threads. In other words, this all done, if you're looking at this code, you would think that that would have to happen after all of these were executing, but it happened actually fairly early on. Okay, so now this is kind of the bare metal way of doing things. As I said, a kind of a better way is to use something called an executor service. So where are we here? So do the same thing. Let's just do 3. And then, but now we're going to take an executor service and there's a class called executors, which produces in this case, a new cache thread pool. So rather than instantiating these directly, I'm using what's called a factory method. And what that will do is that will, just to emphasize what that is. All right, so now we do pretty much the same thing, except that we submit this. So okay, so again, we have to instantiate. What the heck happened? Again, let's do 4 of these guys. And so now instead, I submit. Okay. So that's the part of the reason you want to do this is because these executor services are basically take care of some of the gotchas involved with doing this kind of stuff. Now, what we want to do is in working with the executor service, we basically have a very badly named method, and that's called shutdown. And you would think that a method called shutdown would basically close it down. What shutdown means is that the executor service is not going to be receiving any new, any more stuff. So if we run this now, we see that it basically starts, but then we have, what are you doing? Let's do the same thing here. And what we'll see is, again, notice that it says that we're all done first. And what that tells you is that the shutdown, like all of these immediately return and it immediately goes to the next one. So what, how can we kind of sort of stop that? Well, there's a method called await termination. This is one of the reasons to use one of these things. And we can, the await termination requires to say, here's how much timeout there is. I think by default, they start with 0 days, but that will not do that. Okay, and then it throws a interrupted exception, because in a larger application, you're going to have ways of interrupting. So for example, if you're downloading a file and there's a cancel button, then that would be kind of interrupted. Okay, so what this does, when we say await termination, this says wait until everything is all done. And what that will ensure is that this all done is really when we're all done. So when we run this now, and again, notice that these are still all mixed up. So even when we started them, they went 1, 2, 0. And if we run it again, it's going to be a different one. So here we go, 1, 2, 0, and then it kind of waits a little bit, 0, 2, 1. So what that should tell you is that when multiple threads are running, then it is going to, the order that happens is just going to be arbitrary. So when there are multiple threads running, there's a thread scheduler in Java, and what it does is it selects the next thread by some logic, which is a little bit on the vague side. Okay, so now moving on to this callable idea. What if we see? Here's the problem, or the problem that threads by themselves don't solve. Supposing when each of these threads finish, I'm interested in what in some kind of information about it. In other words, I want, let's say each of these threads is doing some kind of computation. And at the end, I want to find out what's the result of that computation. The problem here is that everything was happening inside this run method, and it's not really returning anything. So one of the, I could sort of save it as some kind of instance variable and then get it with the getter when I'm all done. And again, that's kind of the way it was done previously, but there's a better way, which is with this callable. So let's see what that's about. Okay, so what I'm going to do is I'm going to be spoofing a situation where we have a lengthy computation, and I want to do a bunch of lengthy computations. They're going to take a little while, and return the result. So in a case like that, I'm going to implement callable, and my generic on it is going to be a double. Okay. So, and what I can do, I can specify anything I want here. It can be a double, it can be a string. Actually, I think I'll do a double. Okay, implement all abstract methods. So here's the one abstract method called call, and call is where the execution is going to be happening. Okay, so let's just sort of mark. And again, I want to do the same thing. Okay, so I want to make sure that, what are you complaining about? Missing return stuff, of course. Okay, so I want to say I'm starting. Now what I'm going to do is I'm going to sleep for, let's sleep for 5 seconds. And notice that I put a capital L to indicate that this is actually a long. And okay, so now what number should I return? Let's use our friend random. Random, and then let's return. Next Gaussian. Okay, so that, again, what I'm doing is I'm spoofing a computation, and there are some computations that can be quite lengthy. And for a variety of reasons, I want to do this with many different threads. So each one is, I will say that in projects I'm currently working on, this is exactly what is happening. In one, what is essentially happening here is a simulation of an inventory system over 5 to 10 years, which takes a bit of time. And what the results are actually returned in an object that has all the different values. So that's kind of what happens here. Okay, so you see what's going on. So we're going to create a bunch of these. Each one is going to take about 5 seconds and then just return some random number. And we want to know what that random number is. That's the difference here. So let's see what's involved with that. All right, so again, as before, well, yeah, there's, for a variety of reasons, kind of creating arrays of generics is a bit problematic. So let's start with 3. Why are you complaining? My callable. Okay, so again, we're going to use an executor service to execute this. And now instead of executors, new fixed thread pool, and for now let's have the 3. So now instead of the other, we're going to be running no more than 3 threads at a time. Okay. Okay, so we're going to instantiate it. And then we're going to submit, just as before. However, because I want to save the results, look at the submit. It returns one of these things called a future. Now, the executor service actually instantiates this future, but we want to save that. And so what I'm going to save it in is I'll save it into a set. Call it a results. I'll save it into a hash set. Okay, so now I'll save the result of this into a local variable, and then I'll add it to my results so that when it's done, so when it's done, I'm going to have these futures in there, and I'll be able to call the get method of the future to find out what the results of the callable was. That makes sense. So again, we shut down, and again, as before, since we're shut down just says there are no more callables coming at you. And so we want to await termination. So, and again, it requires this. And tomorrow we're going to get a little bit more into what this sort of logging thing is about. And then when that's all done, and actually, strictly speaking, we should have this as a finally. Okay, so here are the results. And the results are let's just sort of print these all out here. So so the get method, and I can also give it a timeout, and it's because we're going to need another one. We'll surround that with another try catch. And now the Java does notice that there are actually two exceptions that could be thrown by this get. One is an interrupted, which means as we're getting it, we could be interrupted. And then there's execution exception, which means that if some logic goes wrong as we're doing it. Now, notice that there's a suggestion here, can be replaced with multi-catch. So as we've maybe seen once or twice, there are situations in which, as here, multiple exceptions could be thrown. And so because to just sort of cut down on all the clutter, there are cases where there's this thing called a multi-catch. And basically, since we're doing the same thing, regardless of whether it's interrupted or not, then what we have is whether we get an interrupted exception or an execution exception, we can basically treat the results more or less the same as, again, as an exceptional condition. And so now when we run this, okay, so we're starting, oops. Okay, so what happened? Okay, so it's here are the results. Notice that we had the because we were awaiting this. I'm a little ID equals next ID. So that should be Okay, so now let's see what happened. Now our fixed thread pool was only 3. Supposing we make 10 of these. So notice that we're kind of, it starts, I don't know why. Why are they all 0? That makes no sense. I'm actually doing it there. And I'm incrementing. Oh, forgot the static. All right, let's try that again. There we go. See how easy it is to fat finger things. Now, see, notice what's happening. It's only executing them 3 at a time. Why? Because my fixed thread pool said that I was only going to execute 3 of these guys at a time. And so even though I submitted, in this case, 10, they only did them 3 at a time. So that's, why bother with this? Well, it may be that I don't want to overwhelm the resources on the system. And so now I won't get into it here. What I found is that in a multi-core system, generally if you can have kind of up to as many cores as as are there, and that will kind of be the best you can do. When you try to give more than that simultaneously, then each core is running multiple threads. As far as I can tell, the Java virtual machine is very effective at dishing out the threads to the separate cores in that environment. So this is a way to get all kinds of multiple things going on here. Now, and then what we had here, now the one thing that we did not have is we didn't know who was who. So how can we change that? Well, what we can do is we can change this to a string, which is going to mean we have to change this to a string. And then what we're going to do is, instead of that, let's just return a string that tells us for which tells us what's what. So we're going to turn the ID and the value now as a string. That'll tell us which one of these was actually doing it. Okay, so you see what we're making sure that now we're saying, okay, here's the result of this guy, here's the result of that guy, and then now we got to fix all this stuff here. So now our futures have to be strings. This has to be a string, and this has to be a string. And then now, okay. So now instead of just the number, the results are going to tell us who was who. And just to kind of make things go a little more quickly, just because we've seen the other. Okay, so now again, notice just with threading, there's no control on who goes first. So here, the order that they even started was arbitrary, and the order that they finished was arbitrary, even though each of them did exactly the same thing. They just sort of printed out when they were starting. They slept for 5 seconds exactly, and then when they woke up, oops, how did you get there? When they woke up, they got put into the well, well, okay, so actually, strictly speaking, because this is a hash set, we don't know what order they actually finished in, but they, you can take my word for it, they finished in kind of an arbitrary order. Okay, so let's review all this. Okay, first of all, there's, kind of at the bare metal, there's this runnable thing, and we implement runnable and put all of the key stuff into the run method. You should notice in passing that, again, this is everything that we've been doing with Java classes comes into play here. So here we used this pattern of specifying a unique ID without us having to do anything more than just write this code. In this particular case, we wanted to specify how many times we were going to be running this. And let's see, where was it? Yeah, so at the bare metal way, we can instantiate a thread, start the thread, and then we say all done. There are ways of kind of dealing with ensuring that we wait until all the threads finish. But as we saw, there was it just kind of moved ahead. So there is a way of doing that, but since these callables or since using executor service, even if we're using threads, is preferable, we want to instead use an executor service, and we have cache thread pool, fixed thread pool. We've seen both examples. And what we do is we submit an instance of a runnable to the executor service. That's one way of calling it. The shutdown simply tells the executor service, okay, you're not going to get any more threads. It actually doesn't shut it down by, what it shuts down is the ability of the executor service to get a new thread. So just to test that out, let's just to test that out, let's give it another one. And what's going to happen is I'm going to get a runtime exception at line 32 because as I said, because the shutdown simply said, it didn't say to shut down, it said, don't take any more. Okay, then the more expressive one is something called a callable. And then with the idea of a callable is that when we want to return a value, we define a callable, and that specifies a call method, which is where everything that in the runnable would happen in run, instead that happens in call. And we use call when we want to return a value. So here we were just kind of creating we were just generating one. And in this case, if you saw that when I was just returning the number, we couldn't tell who was who. So I changed it to a string so we could tell who was calling it. And the way to, and again, everything we've been talking about as far as what goes into a Java class comes into play. We have a constructor, we have a static variable, an instance variable, and we have local variables here. All that stuff comes into play. You know, that's why I kind of tortured you with that earlier on. And the way to use that, again, is with an executor service. Now we're using it with a fixed thread pool rather than a cache thread pool. And in this case, because the executor service returns one of these future things, what we can do is we can save those future things and then deal with them. We still have the executor service shutdown thing, which says, okay, I'm not going to give you any more callables. We use the await termination to just kind of make sure that we don't advance past await termination until all of the threads that the executor service are executing. And the reason the timeout is important is because if one of the threads gets stuck in an infinite loop, we don't want to be sitting there waiting forever. So here we're going to be waiting for 1 day. You might want to wait a little bit less, like 1 minute would be kind of, yeah. And then finally, because we had saved these future things, we can use the get method to get all the different values. Okay, so that's a sprint through concurrency using threads, runnables, callables, futures, and executive service. So, so you now should have enough to do everything in the assignment except for the logging piece, and we'll talk about logging tomorrow. So if there's nothing more, then we will adjourn for today.